Hold on one second. Yes. And now your next and final task was to try to factor that trinomial. And for this, we try to use that x method. And so to do that, we need to identify the a, the b, and the c. A was 4, b is negative 15, c is 14, and then the key number in the x, of course, is AC, right? So Kyle, this is what I'm talking about, right? I need 100% focus. Or actually, I don't need it, you need it. So AC is positive 56, and B is negative 15. Your task then was to figure out which two numbers multiply to be 56 and add up to be negative 15. And walking around, you eventually, and quite quickly typically, found out that it was negative 7 and negative 8 were the two numbers that worked. So then what we do is we use those two numbers to split our B up. And so that would look like this. And one note, this m squared, as I walked around, that m squared messed some of you guys up a little bit, like it was hanging out there, and it was like you kept on trying to incorporate it into what you were doing, and I felt like it kind of messed you up. So what I'm going to suggest is realize that that's going to be a part of your answer, but maybe leave it out of your steps for a couple of steps. Does that make sense? That way it won't mess you up. Anyways, so when you split the b, you get this, 4m squared minus 7m minus 8m plus 14, and, minus 8m plus 14. And now we are going to, now that we've split the b, now we're going to group it and start the factoring process. So I grouped the first two, I grouped the second two. We want to be super careful about this. What symbol really should be in between those parentheses? Should be a plus sign, yeah. Let's be careful with that. So plus sign goes there. What I'm going to now do is factor the GCF out of the first grouping, factor the GCF out of the second grouping, and see what I've got. So in the first grouping, the common factor is just an m. I'm left over with 4m minus 7. The second grouping, I could factor out either a 2 or a negative 2, but I want to be strategic about this. Which one was the better choice? 2 or negative 2?
I got 7.
So, darn it. Sarah. You can do it you can kind of do it the other way, and you're going to see it's going to work out great. Why? Can anybody explain why I would want to factor a negative 2 out of the second grouping instead of a positive 2?
Make the m positive.
Sorry?
Make the m positive.
And why do I want the m term positive? Because I want it to match the other leftover, right? I want it, and it has to. It really has to match the other leftover. So I factor out the negative 2. And when I do that, I'm left over with 4m minus 7, which is exactly what I wanted. And so maybe you notice that between this term and this term, there is a common 4m minus 7 factor. So that comes out, 4m minus 7. The leftovers, in the first term, the leftover is m. And in the second term, the leftover is negative 2. And so I have this right here. Now I need to remember that this m squared was there all along. I put that back in. And if I were to check that, I would find out for sure that it does FOIL and distribute back to being the original. And as you can see, a lot of you put a ton of good work into this and got it right. Absolutely nailed it. So that's really, really good. Again, a reminder, I've reminded you this every day this week with our assessment coming up next Wednesday. Most of the questions will not have partial credit possibilities. And so you want to make sure that you are checking these and for sure that you got them right. Okay? Because it's relatively straightforward to check them. That took 3 minutes. Do you guys have any questions at all? I am really, really legitimately impressed. You're picking this up really, really well. Can I point something out on yours real quick? Mm-hmm. Will you guys look at the front board? Far left. Sarah, far left front board. Far, far left. It's in a box. So Lexi did a fantastic job. Do you guys see how the line right above her boxed answer is exactly what I have? Exactly what a lot of you had as well? She's got it correct, doesn't she? She's got it exactly right. And then did you see how what she did in her box, she's got 4m cubed minus 7m squared. How would you describe what she did? That's right. Correct. She distributed the m squared back in. And so what she has there is not wrong. She just didn't completely factor it, right? She kind of undid her hard work by redistributing the m squared. So we want to make sure that we leave it in fully factored form like she has above on that line right above her box. Okay, good? All right, really fantastic job. Okay, so grab your notes if you don't already have those out. And we factor completely. And here is where we want to start to look and start to get a bigger picture idea of this process. Take a look at this trinomial right here, and I want you to answer a question. We'll kind of formalize this on Monday a little bit, but I want you to try to answer this question. Is there a common factor that could be factored out, like a GCF that could be factored out in number one? What do you think, Rosie? 7, okay. So let's take a careful look here. Is there a factor of 7 right here? Is there a factor of 7 right here? Is there a factor of 7 right here? So if you're going to factor out a 7, which is not, listen, that's not an unreasonable thing, but all three of the terms have to have the 7 factor in order for that to work. So if you wanted to factor out a 1, be my guest. I don't know that that's going to really accomplish a whole lot. Beyond a 1, I don't think there's a GCF that we could factor out. Does that make sense? So we always want to check that. We always want to look and see. So since there's not a GCF, it's obviously a trinomial. I think maybe the X thing would work out. So let's identify our A, B, and our C. What's our A value? And what's our B? And our C is 49. So our key number is going to be AC. So 1 times 49 is 49. We come over here to our X, and we say 49 goes there. B is 14. Now we got to figure out which two numbers multiply to be 49 and at the same time add to be 14. Keely, what do you think?
7 and 7.
It's 7 and 7, isn't it? So we can then use the 7 and the 7 to help us factor. So I'm going to split the b here. X squared plus 7x plus 7x plus 14. And I'm going to group.
Plus 14.
Or 49, sorry. Thank you. That was just a typo. 49. Thank you, Sarah. So in the first grouping, what's the common factor? X. Thank you, Rosie. And what's left over if I factor out a common X from the first grouping?
Plus 7.
Perfect. Okay. What's the common factor in the second group?
7.
7. Okay. So if I factor that out, what's left over?
7. Oh, X.
X plus...
Wait, where's the X? Oh, there's a 7X. Oops.
Yeah. This is looking kind of interesting because have you guys noticed here that we do it like maybe we expected? There's a common factor of X plus 7. When I factor that out, did you notice that the leftovers are the same? X plus 7. So, yeah. So this is what we call a perfect square trinomial. And what I wanted to point out to you is that all the techniques that we have learned in the last couple of days work here, don't they? All of the techniques we've learned, they still apply. It's just that this answer is kind of special, you know. The two factors are the same. So if you wanted to, you could write this as X plus 7 quantity squared, right? Because it's...
Would it be wrong if you did it the other way, though?
Nope, I'd take either way. I just want to point out that you could write it that way. You might see it that way sometimes. And so, again, don't feel like this is anything totally new. All of our old techniques should work just fine here. So if you guys would, see if this will work for you on number 2. This should be excellent review from the last 2 days. Try number 2, factor completely, and we'll check your answer in a second. And ask yourself, do any of these terms have a common factor that could be factored out, like a GCF that could be brought out? No! I don't think there's a GCF anywhere in there, so we have to at least think about that, right? We should write this down. You should at least think about that. There's not a GCF, so don't worry too much about it. It is a trinomial, and so we're going to use that magic X thought process to get where we need to go. We need to identify our A. And what's our A?
4.
Thank you. And what is our B? Negative 20. And finally, our C is? So in the magic X, the number that goes in the top is always A times C. So that would be 100. The number that goes in the bottom is negative 20. It's always the B. And now we got to make our decision. We got to think about a little bit of arithmetic here. The arithmetic is which two numbers multiply to be 100 and add to be negative 20. It turns out that it is negative 10 times negative 10. Negative 10 times negative 10 is 100. Negative 10 plus negative 10 is negative 20. So here's what we do with that. We take those two numbers and we split up our b with those. So it's 4x squared minus 10x minus 10x plus 25. So at this point, I really haven't changed anything. All I've done is I've said negative 20x is really negative 10x plus negative 10x. Now what I need to do is I need to group it. So I'm going to group the first two, and I'm going to group the second two. And what symbol always goes in between?
Plus.
Plus sign. Good. Okay, now I'm going to factor the GCF out of the first grouping. In the first grouping, the GCF is 2x. The leftovers would be x minus 5. Now in the second grouping, you have a choice. You could factor out a 2, or you could factor out you could factor out a 5, or you could factor out a negative 5. Which one is smarter?
-5.
Why?
Because then it's positive when you divide.
And why do we want it to be positive when I divide?
Because the other one is positive.
Yes, that'll match up. You know what? I left a factor off. That was just a mistake. Nobody said anything. 2x minus 5. Sarah's idea of trying to match the leftovers is right. So I factor out a negative 5. The leftovers then would be 2x minus 5. Make sense? And then you still have a GCF you can bring out. The GCF would be, both of them have a 2x minus 5. Colby? You're left with that. So maybe your final answer could be 2x minus 5 quantity squared, perhaps. Or you could leave it like that. Either way. Warm up toward this direction with a little bit of foil. So if you guys would take a careful look at number 3 right here. It says multiply, and then the two binomials that you're supposed to multiply, aren't they exactly the same except one of them is minus and the other one is plus? Yeah. So this is sometimes referred to as the difference of two squares. We'll talk about that a little bit. The terminology is neat and everything, but the bottom line is we're still going to use the same techniques that we've been working on that you're getting really good at. So take a minute, please, foil it out. Okay, ready, set, go. Foil out number 3. Can you already name something somewhat unique that happened when you foiled this out?
The 15x is canceled.
The middle terms canceled out. They added out, yeah. Hey. No. There. Thank you. So when you foiled this out, you got 9x squared plus 15x minus 15x minus 25. To me, looking at this step right here, and I know that your very next step, you just added those out and you got 0. I get it. But looking at this step right here, I think might be incredibly helpful when you think about what we're going to do here next, okay? So keep that in mind, like kind of burn that image in your mind, 9x squared, and then the most important thing here as far as our pattern goes is the fact that those two middle terms added out, okay? So check this out. Let's take a look at number 4, and I think we'll see a similar pattern emerge with number 4. But number 4 is unique, right? Let's go ahead and identify it's quadratic because we have 16x squared in there. It is quadratic. But what I thought we would do is look at it and identify the A and the B and the C. So what would you guys say for number 4? What's the A value?
16.
The A value I would say is 16, right? We're going to use like kind of our standard technique here. So the A value is 16. And the B value is?
100.
Ooh. Do you see how the B seems to be missing? So the B is 0. The B is 0. It's like 0x. It's just not there.
Oh, I'm just doing the wrong thing.
And C
Is negative 100?
C is negative 100, correct? So here's where this is a little bit unique. We're going to be using the same techniques. Again, you're getting good at this, but check this out. Your AC is going to be what?
Negative 100.
Pretty gigantic AC, right? And your B is 0. So do you remember that pattern? Listen, you remember the pattern we just saw with the plus and minus thing and the middle terms adding out? Yes, when we did the foiling? when you start to think, man, oh man, which two numbers multiply to be negative 1600 and add up to be 0? Don't these two numbers have to be the same number, but one of them's positive and the other one's negative?
Yeah.
So let's start thinking, which numbers would be big enough to get there? What do you think, Keely?
400 and negative 400.
What do you guys think? Are those the right numbers?
Oh, I didn't, yeah, they are.
Check them. Use your calculator and check. Do those numbers multiply to be negative 1600?
Yeah. No, was it 40?
Wait, it's
It's 40s. Yeah, isn't it negative 40 and 40? These are a little bit too big. So it'd be
it would have been.
Sarah, the exclamations of wait what don't really serve much purpose, okay? Oh my goodness, Sarah.
Yeah.
So that's all I'm going to say because that's about all I can say calmly right now. Am I clear?
Yeah.
You know what I'm talking about?
Yeah.
It's going to stop, correct?
Correct.
Good. Okay, so negative 40 and 40. So the 400s were a good idea, weren't they? But they were just 10 times too big. But it was a good idea. So what we're going to do now is we're going to go back and split the b. So it would be 16x squared minus 40x plus 40x minus 100. Okay, so we're getting that same pattern we got when we tried to FOIL this out. Numbers are going to get kind of huge here. Obviously, you can see that. But because you know the pattern, it should be really fairly straightforward. What's the common factor between 16x squared and minus 40x? 4x, you're right. So what's the leftovers if you factor that out?
4x minus 10.
4x minus 10. What's the GCF we could factor out of the second? 10. Yep, so it'd be plus 10 and then 4x minus 10. So do you see the... Oh, I'm sorry, Rosie, go ahead.
I don't get why you can't just be like, what goes into 16 that's equal.
So that's one way of doing it. What I'm trying to do is be consistent. What I've found over the years is when I, honestly, I would like to teach it that way. I found that roughly a quarter of my students pick it up like that. I'm trying to be consistent. So
I just wrote down
can I show you a pattern? Can I show you that alternative? Okay. So then the common factor is 4x minus 10. Oops. And the common, or the leftovers would be 4x plus 10. And maybe you see that fits that nice difference of squares pattern we kind of investigated earlier. Now, Rosie's suggesting an alternative, and I think that it's a good alternative, but I'm always fearful of showing this because I feel like at the end the reaction is kind of like Sarah's, like wait, what? I'm lost. So can I show you that with number 5 real quick? Show you what maybe you could do with number 5? If you recognize this, and this takes recognition skills, and by the way, recognition means that you've seen it enough to where you have seen it enough, right? Like, for instance, if you showed up, said hi to your best friend, and your best friend was like, who are you again, and what's your name? You'd be a little nervous because they should recognize you, shouldn't they? Because they've seen you a lot. So this takes a lot of seeing to see this. But did you notice, looking at number 5, do you notice how this term is basically 9x squared, and the other one is another perfect square, which is a 7? So in this pattern, when the b is not there and the b is 0, you could actually go directly to this and say it's going to be 9x and 7, 9x and 7, and then the signs in between them would be plus, and then the other one would be minus. And of course, if you look at this and you're just like, oh my gosh, that looks like black magic, how did you do that? You could check this, to be honest with you, I think this would be a worthwhile exercise. You could check this by refoiling it, and you would see exactly what happens. Check that out. You get 81x squared, and then you'd get minus 63x. What would your other ones be? Plus 63x, right, when you FOIL this? Minus 49. And just like we practiced, these would add out, and you'd end up with that original. So that is a very viable thing, and if you see it, great.
So I just did it on a test.
I have no problem whatsoever. In fact, I would love it if you did see that. That'd be great. Yeah, Lexi.
That was my question.
Yeah, totally. If you can see this, go for it. But in the past, my past experience has told me, and maybe I'm off, maybe you guys are just different. My past experience over the last 10 years here has been when I show that, people are like, what? Because it's different than the other stuff, I'd like to be consistent. So if you don't see it, it's fine. You can just do it the old way too. So, okay, so on Monday, what we're going to do is we are going to kind of go back over all of the factoring stuff, kind of give you a comprehensive plan about how to approach these, then our quiz will be on Wednesday. Okay? Hope you have a wonderful weekend. I will see you.